My topic is climate change in forests and the alternative futures we would have with low and high emission scenarios of CO2 in the future. And it's important to acknowledge that I stand on this huge body of scientific knowledge that goes back 200 years to the time Fourier discovered that we have greenhouse gases in the 1820s. Tyndall showed that CO2 actually plays a role in climate change in the 1860s, and then Dr. Seuss here was the one who proved that excess CO2 in the atmosphere came from fossil fuels, and that was in the 1950s because CO2 coming from fossil fuels has a unique isotopic signature. And by the way, he's not the Dr. Seuss you're thinking of. He did not write The Cat in the Hat. He was an atmospheric chemist. And then the big player is Arrhenius, a Swedish scientist who spent 2 years with paper and pencil all day long, every day, doing the calculations needed to project what would happen to the mean temperature of the world if we doubled the CO2 content. And he published that in 1896. And his answer was 4 to 6 degrees Celsius. And that's not far off from the latest generation of models that we have now that's in the range of 3 to 4, and a few of them are even getting 5 degrees Celsius, so there's a substantial overlap there. So he did a good job, considering it was 1896 and he didn't have any satellite data whatsoever. And before plunging into the forest detail, I just wanted to make a few comments about why is global warming so important? Why do scientists think it's important? Because the largest mass extinction in Earth's history, which was the end Permian extinction, as well as 3 of the other 5 mass extinctions that we've had, was caused by an episode of global warming due to rising CO2 levels. In those cases, it was from volcanoes that resulted in acidification of the ocean and loss of oxygen in the oceans dying, and then the chemicals coming out of the oceans like hydrogen sulfide killing the species on land. So this time, humans are the volcano. So we're emitting as 99% of all the CO2 going into the atmosphere at this point, and all the volcanoes on Earth are doing the other 1%. We don't have any volcanoes like the one 250 million years ago that filled an area with lava about half the size of the 48 states, a half a mile in depth with lava. We just don't have volcanoes like that today. So we're on one of the tipping points in the world. Northern Minnesota up to Edmonton is this boreal forest tipping point where if that forest dies, it could emit a lot of CO2 to the atmosphere, billions of tons, and put us over a tipping point where instead of being able to stop at 3 or 4 degrees Celsius of warming, it would get away from us because we'd be past a tipping point and we would add another 8 to 12 degrees Celsius of warming that we would not be able to stop. So we need to stop at 2 or 3 degrees at most. If we go past that, we're likely to trip one of these tipping points and be out of control. So how has climate been changing in recent times? This is a composite of many different sources of evidence, ice cores, tree rings, lots of different things showing that we were at the middle of the interglacial. We're at the peak of it about 7,000 years ago. For the last 5,000 years, it's been cooling. That's the natural trend due to the orbital parameters of the Earth and the natural glacial cycles. And then the red line here at the end is what's happened in the last century, which is warming caused by burning fossil fuels by humans. And then this is what happens if you stretch out that last red bar and look at the global temperature record from weather stations, which dates back to 1880 here. And you can see the rise in temperature year by year with some wiggles in opposite directions. It's like the stock market. It goes up over time, but it also slides back. It's not a smooth process. Currently, our CO2 is as highest it's been in 3 million years. This shows the 800,000 years of that 3 million year record, and you clearly see the 100,000 year glacial cycles here staying between 180 and about 300 parts per million CO2. Now we're over 400 million, 400 parts per million, excuse me, not 400 million parts per million, 400 parts per million CO2. And the question is, are we going to go up to around 500 parts per million for a low emission scenario, or up to 900 parts per million or more for a high emission scenario? And those two alternatives make a huge difference for what might happen to us here. And you can see on this map, we warm up maybe 1 or 2 degrees Celsius for mean annual temperature with the low emission scenario, which is 3 or 4 degrees Fahrenheit versus 6 or 7 degrees Celsius for the business as usual or high emission scenario by the end of this century. So Minnesota is at a very interesting place on the planet. We have 3 biomes here. We have the boreal forest, the coniferous spruce, fir, jack pine, along with birch and aspen. We also have temperate deciduous forest in the lighter green, that's maple, oak, and basswood. And we have grasslands in Minnesota. Used to be native grasslands, now they're corn, but still mostly grass, I guess. Having these southern edges and western edges of these biomes makes us especially sensitive to a changing climate. The only other place like this that I can see in the world is in Kazakhstan, where these 3 biomes come together, and maybe in northeastern China, but they wiped everything out so much there that you can't tell because there is no natural there. Anyway, so here's the boreal forest, balsam fir, white spruce, black spruce, paper birch. This is Tetagouche State Park on the north shore of Lake Superior. I'm sure many of you have been there and looked at this same view at the Tetagouche rest stop. This is our other forest biome, sugar maple, basswood, and red oak forest. This is 40 miles to the south in the Cannon River Wilderness. And here's the grassland biome. So that's what we have in Minnesota. And where are we going for a little more detail here in terms of temperature? And notice I've shown summer, which is June, July, and August temperature. That's because summer temperature is far and away the most important factor determining whether we'll have boreal forest, temperate forest, or prairies in a given place. And so for the low emission scenario, by the end of the century here, we'd be about 5 degrees Fahrenheit warmer. This slide actually has Fahrenheit on it because Don Wubbles and I used this slide in Washington, D.C., and there isn't Celsius in Washington, D.C. So we actually have a slide with Fahrenheit. So 5 degrees warmer, which would make the Twin Cities about like Des Moines, Iowa, versus the high emission scenario, which would be about 13 degrees warmer in summer, and that would make the Twin Cities like this little town here, 40 or 50 miles west of Kansas City, Manhattan, Kansas. So do you want to be like Manhattan, Kansas, or do you want to be like Des Moines? Personally, I don't want either. I want to stay totally the way it is now, but I'm not sure that's a choice anymore. What would happen with that high emission scenario to our tree species? Well, we have lots of species with southern edges of range like balsam fir, black spruce, white spruce, paper birch. This shows balsam fir, and the bright colors are where it's very abundant. And with that high emission scenario, by the end of the century, we would essentially lose that species, along with a lot of others. So this whole suite of species, black spruce, white spruce, balsam fir, paper birch, aspen, red pine, and jack pine, would essentially be gone from Minnesota. And even in northern Minnesota, it would be replaced by this suite of species. So imagine the boundary waters kind of redecorated with bur oak and basswood and bitternut hickory, Kentucky coffee tree, hackberry, elms, A lot of people don't know we have 3 native elms in Minnesota, and I'm sure you've all recognized these as American elm, red elm, and rock elm. So switching that group of tree species for this group in northern Minnesota, southern Minnesota would still have this group. We have this group now. It would stay with us. So what does it take to make a boreal forest? Well, I had a PhD student, Nick Fisichella, who's now at Acadia National Park in Maine, who visited all these black stars and red triangles here. Gradients from places with cool summers like Grand Marais out to places like Bemidji that are right at the edge of the prairie. In Grand Marais, it's almost all spruce and fir, very little maple and oak, and out here it's mostly maple and oak at the edge of the prairie and very little spruce and fir, but all these places had spruce and fir, boreal and temperate maple and oak growing together. And he looked at the growth rates of saplings, both the ring growth, the diameter growth, and the height growth. These are saplings about 3 to 8 feet tall in the understory that represent the future of the forest when the current canopy trees die. And this is what we found. There is a crossover point at about a little over 65 degrees mean summer temperature where boreal and temperate species grow the same amount. If it's warmer than that, maple and oak grow more than spruce and fir. If it's colder than that, then the boreal conifers grow faster. So if you're in a place like Duluth or Ely, and historically they were at this location here where it was maybe between 63 and 64 degrees mean summer temperature, and the boreal conifers were growing faster than the temperate species. Now they're right at the crossover point, and within a few years they're going to be at the high end of this temperature scale here, where the temperate trees will be able to invade the boreal forest and replace it. And here's a place where the invasion of boreal forest is already happening with the warming that has already occurred. And you see here sugar maple and balsam fir in 2016. Well, I was in this place in 1979, and it was all boreal trees. You could not find a maple tree anywhere here. And I revisited it, and here's this maple tree there, and it's growing just as fast as the fir trees. So the warming that has already occurred has made a difference. And temperate trees are invading the southern parts of the boreal forest right now, and that will accelerate. What about the prairie forest border here, which determines whether we'll have any forest at all, whether boreal or temperate forest? Maybe it won't be forest at all. And I had another PhD student, Nick Dons here, who's now on the faculty at University of Wisconsin-Superior. And he studied this for his PhD, and he discovered that the historic prairie forest border as it existed at the time of European settlement basically sat right where the annual climatic water balance or moisture balance was 0. In other words, the evaporation was exactly equal to precipitation. Those are the brown areas here. And forests occurred in the green and blue areas where there's more rainfall than evaporation. So forests require an excess of moisture in order to survive. And the question is, where is that going to go? Where is that 0 water balance going to go if we have that business as usual scenario and the summers warm up 13 degrees, and it's like Manhattan, Kansas? You can imagine huge amounts of evaporation will take place. Well, I'll show that in a minute. So we have these mapping rules here, biome climate envelopes here, and again for the crossover point for the boreal versus temperate is about 64.6 degrees. So you get mixed forest with a couple degrees on either side of that. If it gets warm enough, it'll be purely maple, oak, and basswood, which is temperate forest. And if it gets cold enough, it'll be purely boreal forest, but it's mixed together in the middle. And then looking at the climatic moisture index, if it's 0, that's where the prairie forest border is. If you get into the negatives, negative 2 inches or more per year, you're getting prairie. And if you have positive 2 inches more rainfall and evaporation, you're into forest. So what happens when you just take these rules and make a map right now and for future scenarios? Well, that's what this shows. So on the left here, you see the current biome mapping for the climate as it stands from 1980 to 2010, or as it stood from 1980 to 2010. And you see the boreal in the dark blue here in northeastern Minnesota, the mixed boreal and temperate in the light green, the temperate maple, oak, and basswood forest in that kind of yellowish beige, and then the prairie out here at the edge of the Dakotas. Notice the prairie forest border has actually moved to the west. Iowa is now almost wholly a forest climate, and so is southwestern Minnesota. That's because we've gotten more rainfall in recent years than we did several decades ago, but summers have not warmed up a lot. Winters have warmed up a lot, but summers have only warmed up a little bit, so precipitation has gone up a lot, but not evaporation, so it's a net moisture climate, and the prairie climates that support prairie have pushed off to the west. So that didn't surprise me, knowing what had happened to the climate recently. And prairie managers can tell you this is the case because they have to fight really hard to keep their prairie remnants as prairies, to keep trees out. So with the low emission scenarios where we would go by 2070 in this scenario here, so we took some of these general circulation models for the Earth that project the future. We took 3 of them. This is a typical one for a low emission scenario. Still some boreal in northern Minnesota. Still mixed conifers in most of northeastern Minnesota. A lot of temperate forest. The prairie pushes in a little. Still recognizable as Minnesota. If you look at one of the high emission scenarios, then the boreal is gone completely from Minnesota. There isn't even any mixed conifer or boreal and temperate forest. It's just maybe some oak and maple forest in the tip of the arrowhead. The rest of the state, prairie, few little, where you have the big hills in southeastern Minnesota, there'd be enough topography there to have persistence of small areas of maple, basswood, and oak forest, but basically it would be a prairie state. And so I was 5 months ago quoted right up front on a front page article in the Washington Post as saying, we have a perfectly good Kansas now, we don't need a second Kansas in Minnesota. And that's basically why I haven't been left alone by reporters since April, because of that quote in the Washington Post. So everybody wants to hear about this now. So all that is prairie for a high emission scenario with huge summer evaporation. What does that look like in pictures? So if you take the boundary waters right now, you can ask the question, where is an analog climate? In other words, where is a place that right now has the climate we're projecting for the boundary waters in the year 2070? Well, around Granite Falls, Minnesota, the orange star here is such a place. And it turns out it's called Granite Falls. They actually have similar rock types and physiography as the boundary waters. So here you see the boundary waters. This is black spruce, which is one of our major boreal conifers in Minnesota. Doesn't just grow in bogs, it also grows on well-drained rocks, as you can see here. 2.8 billion year old rocks in the boundary waters, and you warm up the summers about 8 degrees Fahrenheit. And this is nice outcrops natural area near Granite Falls, Minnesota. Prairies, scattered oak trees here, very similar physiography. The rock's a little older here. This is 3.6 billion year old gneiss, which is metamorphosed granite. And it's one of the 4 oldest rock formations known on the Earth. So it beats the boundary waters by almost 1 billion years in age, but it's very similar physiographically and chemically. So the difference between this and this in shallow soils on bedrock is about 8 degrees mean summer temperature, 8 degrees Fahrenheit. And of course, if you change the vegetation, you're going to change the wildlife as well. For example, lynx will leave Minnesota if it gets that warm, and bobcat will take over. Moose will leave. Moose have already declined in northwestern Minnesota. They're still holding on in northeastern Minnesota, but they've declined compared to 30 years ago. Replaced by deer, which is adapted to a warmer climate than moose. And for birds, I could have picked 100 different species, but I picked blackback woodpecker being replaced by red-bellied woodpecker. And last time I was up north to the Hubachek Research Center near Ely, I told the naturalist I was projecting red-bellied woodpeckers would come in, and she said, oh, they're already here. So I was really shocked by that. So change the vegetation, you change the wildlife. Can you have a moose in Granite Falls or Omaha? Well, sure. If you give the moose a swimming pool filled with ice water, you could have a moose in that climate, but it's not going to live there otherwise. So with that, and this image of the boundary waters with the currently existing forest reflected in the water and the forest above the water digitally erased and replaced with a picture of prairie from southwestern Minnesota by David Luke, who was a professor of photography at, I think, Normandale College down in Bloomington. So did a whole bunch of these showing the current and future boundary waters with a high magnitude of climate change. And I just also wanted to mention the National Park Service and the Environmental Trust Fund for funding this research over the last several years, as well as all these people down here who either did most of the heavy data analysis or donated money or did something that was significant. So if we have time, I'll take some questions. Maybe I should stop share so I can see who all is here. Oh, there's Anne Marie. Anyway.
Lee, is there anything we should be doing other than lowering carbon emissions? In other words, will these changes happen naturally, or is there some things that we have to be concerned about that we have to plant or something, or is that not even a concern?
If we are headed towards the prairie climate in northern Minnesota, we are going to have to put a lot of the hundreds of prairie species, or thousands even, of prairie species in southern Minnesota in the car and drive them north in a process known as assisted migration. Some of them will be able to get there on their own, a lot will not. And if it's going to be a savanna, we want it to be the best savanna it can be. If it's headed that way, you cannot make it continue to be a boreal forest. But I would hope that we would reduce emissions enough that we could retain conifers in northern Minnesota and therefore negate having such a huge management problem and avoid having all that forest die and put all of its carbon into the atmosphere in the next few decades.
Lee, this is Brick. Thanks for the presentation. Very interesting. I have a couple questions. One is, did your moisture evaporation model incorporate the interactions with the prevalence of or incidence of fire, and how that would be maintaining a prairie system versus allowing trees to continue to regenerate or germinate from seed?
Yeah, that's a really good question. And the answer is that the high frequency of fire, where you have fires every few years and trees can never grow because they're embedded in the grass and they get burned over and over, is so highly correlated with that climate, with the negative moisture balance, that you can't take them apart. So if you model one, you're modeling both. So those areas with the negative water balance would have very frequent grass fires, and that would just reinforce the absence of trees. And it's interesting that the original prairies in southwestern Minnesota were mostly wet prairies. Most of the farmers out there have had to tile their fields and drain their fields.
Mm-hmm.
Even when it was soaking wet, you couldn't support trees there because of the droughts that occasionally occurred that would leave everything high and dry, and grass can withstand that and trees can't, and the grass leads to contiguous fuel for fires that are way more frequent in grasslands than in forests. So there are a lot of mechanisms there that go along with that negative water balance that reinforce the forest versus the prairie.
Sure. My second question is, I trust you're familiar with Curtis's Vegetation of Wisconsin book. And in that book, was it published 57, 59, somewhere on there? And there's several references to relic communities. In southern Wisconsin, southwestern Wisconsin in particular, there'll be relic communities, glades of pine, cedar, et cetera, on the north sides of the drumlins and other glacial features. Would you expect us to, in the northeastern Minnesota, to have these glacial relics in the bogs, north sides, the south sides of lakes that have a sharp slope, for example, that are facing north? Would you expect something similar to happen here?
Yeah, and first I should say that the Vegetation in Wisconsin is one of the great classics in the history of the science of ecology. I read it when I was 12 years old, about 10 times, and to this day I remember every word in it. And it's the reason that I decided to become a forest ecologist when I was 12. I decided I was going to do a PhD in forest ecology at the University of Wisconsin, where Curtis was, and was going to continue on where he left off. And as we know, that's what happened. So it's a great book. Yeah, we could have what we now call them refugia. The North Shore could have cold water upwelling because there's water several hundred feet deep just offshore. And that could upwell along the shore and maintain a thin strip of boreal forest along the North Shore. Some of the bogs could be big enough to, because they're in low points on the landscape that receive cold air drainage at night, they may be maintained. We have a tamarack forest in the western suburbs of the Twin Cities that's 100 acres in size, that out in Medina, which is a relic of boreal forest, and it has maple basswood forest all around it. So the biome all around it changed and it stayed the same. The problem is that would be the next step in the science and modeling to go to that finer scale, where we would have all the data on the scale of a meter, or which is close to a yard, instead of a square kilometer, which is what I was the models that I showed you. And we're ready to do that. We just don't have the funding for it. And we could actually model where those refugia would be on the landscape, because you can now model the movement of air at night and where the cold air settles. There are mathematical equations that will do that. It's just that doing that for the whole landscape at the scale of a meter requires a really big analysis using the University of Minnesota supercomputer facility. So, which requires some money to do.
Polly had a question. Polly, do you want to do it, or do you want us to read it off the chat?
Yeah, go ahead and read it, Tim. Thanks.
Okay, Lee, her question is, could you comment on the loss of red oak along the planned bicycle trail on Highway 87 between Frezzi and Park Rapids? Any recommendations on replacing the red oak?
Yeah, well, I'm not familiar with those exact trees, but red oak is a problem everywhere. And the reason is red oak is basically an artifact of European settlement. I mean, there was only a little bit of red oak in forest before European settlement, because either it was a dense forest that didn't have much red oak, or it was an open prairie, and it was mostly bur oak and white oak. I mean, there was always some red oak, but the big increase in red oak came because people killed off the passenger pigeon at the time of European settlement, and the passenger pigeon ate almost all the acorns that red oaks produced across the whole continent, or the eastern half of the continent. And just after settlement, there were hardly any deer. Deer eat red oak seedlings. There were hardly any bear, hardly any turkey. They ate the acorns as well. So red oak kind of took off and was an artifact of European settlement, but now we think of it as being normal, but the conditions out there just are not suitable to regenerate it. So essentially deer will eat every last red oak seedling, so you have to protect every one individually from deer. So it's not a climate issue so much as it is a whole suite of changes in the environment over the last 100 years. That means it's just not suitable for red oak regeneration right now. One positive of a warming climate is that red oak is more drought tolerant than sugar maple and basswood. So as the water balance becomes more negative and droughts are more severe, red oak would do better than maple and basswood, and it might start competing with those and do better maybe in 3 or 4 decades from now if the climate continues to warm. So there's always something positive about any change, even climate change. If you're a red oak lover, a warming climate would be good.
And Lee, this is Rick. Does that apply to northern pin oak as well?
Yes, that would apply to pin oak too. Yeah, which is very closely related to red oak.
Okay.
In fact, most of the oaks you see out there are hybrids of those two species.
All right. Unless we have any other questions, we're going to move on to Anne Marie.